All right, so today we're going to be moving on to packet 8. So let's take a look and see what's going on here. So for packet 8, looks like problem's number 40. And for problem number 40, it says the population of a city in 2005, so that's the year, was 36,000. And it says by 2010, the population had grown to 43,800. It says, assuming that the population of the city has grown linearly. Linearly means we're going to have an equation in slope-intercept form since 2005 and continues to grow at the same rate. That means slope. What will be the population in 2015? All right, so we have to figure out what would the independent and what would the dependent variable be. So dependent means it depends on the independent variable. The independent variable we could change, and that affects the dependent variable. The independent variable is x, the dependent variable is y. So the question is, does population depend on what year it is, or does what year it is depend on the population? Well, that second one doesn't really make sense. It would make sense that the population depends on the year. So what we could do is we can make points. We could let x be the year. So in 2005, the population was 36,000. And in 2010, the population was 43,800. Might be better if we don't include that comma. So it's asking us if it grows linearly. We're going to come up with an equation in slope-intercept form, and then we want to plug in 2015 and see what the population is. So we've done this before. The way that we use slope-intercept form is the first thing we have to do is figure out what our slope is. And to find the slope, we subtract the two y values, and we put that over a subtraction of the two x values. So it doesn't matter what order you go in. I always draw arrows so I'm consistent. 36,000 minus 43,800 divided by 2005 minus 2010. Let's see what that is. So 36,000 minus 43,800 is negative 7,800, and 2005 minus 2010 is negative 5. If you simplify this, you would get the slope, 7,800 divided by 5, of 1560. That's what our slope is. So then when we go to write an equation in slope-intercept form, we put the slope in for m, and we pick one of the 2 points. Doesn't matter which one you pick, and we'll use that x and y value to solve for b. So if we let y be 43,800, and we let x be 2010, now we just have to figure out what b is. Well, 1560 times 2010 is 313,500. And if we want to get b by itself, we're going to have to subtract that number on both sides. And we would get that b, let's see here, is negative 309,800. So tying together all of our components for y is equal to mx plus b, we got that the slope was 1560, and our b value was negative 309,800. The question's asking us, what's the population in the year 2015. So if we plug 2015 in for x, let's see what our population is. I'm going to type this into my calculator. And I'm getting the population is 51,600. That would be our answer for part A here. Now for part B, it's saying which expression is an appropriate exponential model for the population of the city. Let t represent the time in years since 2005. So let's take a look at what we know. We know that in 2005, the population was 36,000. And we know that in 2010, the population was 43,800. So for part B, it's asking us to test out some models. All right, so let's plug in and let's see which one works. Doesn't matter which one we use. I'll use this for x and we'll use this for y. And it's saying let t represent the time since 2005. So in 2005, t would be 0. In 2010, t would be 5. T represents the time since 2005. So let's plug in and let's see which one is appropriate. Option A, it says that y is equal to 36,000 times 1.04 to the t power. And I'm going to use this very first one to test it. So if we put 0 here, anything to the 0 power is 1, we'd get 36,000. Actually, we'd get the same thing for all of these. So I don't know if that's the best point to test. Let's pick another test point. Part B says 1.04 to the 5t power. And then we have part C is 1.217 to the t power. And then part D is 1.217 to the 5t power. So that first point, we kept getting 1 for all of them, so that might not be the best point to test. Let's try this second point instead. I'm going to plug in t for 5, and we're going to see which of those options gives us the closest to 43,800. So I'll type them into my calculator, and I'll write down what it is. So I'm going to put 5 in for t. So 36,000 times 1.04 to the 5th power. My calculator is telling me that this is 43,799.5. Well, that's close to 43,800. But let's try the second one. 36,000 times 1.04 to the 5 times 5 power. That's 95,970.1. That's not as close as part A, so I'm going to get rid of that. Next, I'm going to try 36,000 times 1.217 to the 5th power. And I'm getting 96,107.1. Again, that's not as close as part A, so I'm going to get rid of that option. And I'm going to try part D, 36,000 times 1.217 to the 5 times 5 power. And that's 4881653.6. Obviously, that's a huge number. 4 million is nowhere near close to what we were supposed to get. We're supposed to get 43,800 and 43,799.5 is pretty darn close. So I'm going to say that the answer for part B is A. Let's go to part C now. For part C, assuming that the population of the city has grown exponentially since 2005 and continues to grow at the same rate, what will be the population in 2015? So this is telling us to use our answer that we just figured out. Y is equal to 36,000 times 1.04 to the t power. And remember, t is years since 2005. And we want to figure out what happens, or what's the population in year 2015. Well, you can't put 2015 in for t, because t is years since 2005. So 2005 to 2015, that's 10 years. So t would be 10. That's what we're going to put in for t. So I'm going to type that into my calculator. 36,000 times 1.04 to the 10th power. And my calculator is telling me the answer for the population is equal to 53,288.8. Usually when we're talking about people, we always round to the nearest person. That would be our current population. Now it looks like we have one more part here, part D. Now for part D, it says another town's population could be modeled by the function P of t is equal to 27,400 times 1.66 to the power of t divided by 10, where P is the population and T represents the time in years since 2005. So it's the same as before. T is equal to the number of years since 2005. Based on the model, by approximately what percent does the population of this town increase each year? All right. Based on this model, by approximately what percent does the population of this town increase in each year? So let's figure this out. On a per year basis, let's just plug in numbers. Let's figure out the population in year 2006. That would mean that T would be 1 year since 2005. So 27,400 times 1.66 to the power of 1 over 10. And we'll figure out what the population is in the year 2007, where t is equal to 2. And we'll figure out what that is as a percent. So 2 years since. All right, so I'm going to type that first one into my calculator. 27,400 times 1.66 to the power of 1 divided by 10. And that comes out to 28824.5. And in 2007, I'm going to type the same exact equation, but I'm going to write it to the power of 2 over 10. And that's 30323.0. Now we're looking to see by what percent does it increase per year. So the way we figure out percent increase is we use the formula new minus old divided by old. So for this problem, it looks like if we let 2007 be the new, 2006 represent the old, The new population would be 30323 minus the old 28824.5. We're going to divide that by the old. Now let's see what that is. 30323 minus 28824.5 divided by 28824.5. I'm getting an answer of 0.05198, which as a percent, we move the decimal 2 units to the right, which would be about 5.2%. And it looks like that would be option C. All right, so that's it for today's class. We'll pick up where we left off tomorrow. Thank you very much. Have a nice day.